Hello, my name is Felix Stefanus from Computer Science Department from Bina Nusantara University with my friend Hansel Octavian Lesmana, also from the Computer Science Department from Bina Nusantara University. Today we are going to talk about our research paper, Enhancing Sign Language Recognition Using Convolutional Neural Networks, or CNN, for improved accuracy in Indonesian Sign Language, which we will submit to IKT. Okay, introduction. Sign language is a language used by the hearing and speech impaired that mainly uses body language and lip movements. There are two main sign languages in Indonesia, which is CB and Bisindo. CB is a recognized formal sign language in Indonesia that was created to adapt sign language to Indonesian. Bisindo, however, is a more informal but more natural and expressive language. Since there are communication barriers, we decided to make an AI-based sign language recognition system using CNN for Bisindo to help us understand sign language better. Recent studies using CNN for Bisindo achieved up to 97.5% accuracy, proving CNN effectiveness in image recognition. Next. Okay, methodology. First is our dataset. We use the dataset from Kaggle called Citra Bisindo, which contains 12 images for every alphabet from A to Z. And the architectural model, we use MobileNet V2 with 5 layers. The first layer is 2D global average pooling. The second is batch normalization. Third is dropout. Fourth is dense layer with ReLU. And 5 is softmax output layer. And our training, we uses transfer learning and uses a pre-trained ImageNet weights and fine-tune the last 30 layers to adjust to the characteristics of the alphabet. Transfer learning is chosen because we don't want to train from scratch, and we want to take advantage of the visual features that already exist in a large dataset. We use 80-20 split on the dataset with accuracy for the correct classification, F1 score to see the precision and recall, and confusion matrix to display misclassification.
So next, we will discuss about the first table first. We can see that the training accuracy increased from 0.36 on epoch 5 to 0.98 from epoch 33. And the second one is the validation accuracy also improved from 0.2 to 0.9. And we can see the training loss drop sharply from 2.2 to 0.09. Okay, and the last one is validation loss decreased from 2.5 to 0.06. Okay, we can see the second table is loss function per epoch. Okay, the model shows good performance during training with a steady decrease in loss. The training loss and validation loss graph show a downward trend without any sudden spikes. This can be an indicator that the model can learn from the training data without memorizing it or overfitting the existing data. The loss function we use is categorical cross entropy, which is generally used in multi-class classification. The loss value at first epoch, 4.67, is pretty high, but it managed to drop significantly at the 33rd epoch in 0.0673. Meanwhile, if we look at the training accuracy and validation accuracy in the third table, it also shows a very positive trend, which is consistent until the end of training. The training accuracy value itself reached a figure of 98.4% at the last epoch. And if we look at the last validation accuracy, it is in a range of 98.1%, which indicates that the generalization of the model is quite good. There is no big difference in training accuracy and validation accuracy itself. This indicates that the model is quite stable on the given dataset. We used to image for every alphabet as evaluation material. The evaluation results show that the model is good. Because the sign language image, the accuracy of the model itself in this data reached 98.08% with an F1 score value of 97.75%. From the result above, we can conclude that the model is able to learn from the data well and learn effectively. Okay, and the last is conclusion. The conclusion is, in short, we developed the research to able to recognize the Bisindo Sign Language using CNN model MobileNet V2. We achieved a high performance and validation accuracy of 98.08% and F1 score of 97.75%, despite minor misclassification in class Q and I. The overall result demonstrates that the model is effective in recognizing the Bisindo alphabet and show great potential for real-world application, as especially in improving communication with the hearing and speech impaired. It's all. Thank you.